let's jump right in here. A major reason to be able to take a cyclical situation and write a particular sinusoid to represent this situation is to use the equation to predict future values of y, or to calculate x when you're given y. So just like with algebra, the reason we ever find a function is so that we can use it to find future values and to predict things in the future. For instance, you can express the time of sunrise as a function of the day of the year. With this equation, you can predict the time of sunrise on a given day by simply evaluating the expression. Predicting the time on which the sun rises at a given time is more complicated. In this standard, we'll learn graphical, numerical, and algebraic ways to find x for a given y value. We've actually done a little bit of this already in the standard we were working on the last couple of days, but we're going to do it with actually functions now. Alright, so the symbol, when you see the symbol cosine to the negative 1 of 0.3, we've kind of talked about inverse functions, but what that notation means is that it's the inverse cosine evaluated at 0.3, meaning an angle whose cosine is 0.3. Because normally this is coming from an expression that looks like this. So we're looking for an angle whose cosine is 0.3. That's the way we would write it in order to find that angle. By calculator, in radian mode, if you were to punch out the inverse cosine of 0.3, you would end up getting 1.266. The inverse cosine relation includes all arcs or angles whose cosine is a given number. The term that we will use from now on is arc cosine, or arc cosine to abbreviate. So arc cos. Meaning, when you see arc cos, it's the same thing as saying cosine to the negative 1. There are just two different ways to write it. But this is reminding us that we're actually finding the angle or the arc associated with that value. We're not finding the y value, we're finding the x. So that's a good thing to keep in mind. So arc cosine of 0.3 means any arc or angle whose cosine is 0.3, not just the function value. For example, if we were to draw the unit circle, you have this expression. That's what this means here. That x, or your angle, is equal to the inverse cosine of 0.3. Or you could say, if we were to write it in the other notation, arc cosine of 0.3. They mean the same thing. So if you look at where where this expression is 0.3, and actually we found out that this was 1.266 and this was 1.266. If you're looking at 0.3, it's about right there. If this is the unit circle, that's 1, 0 as a point. There's 0.3. If we were to plug that in, according to this function, we would get two values. It matches up with two different y values on this unit circle. Matches up with 1.266 and negative 1.266. But that's because this arc this way and this arc this way are the same measurement. If you keep in mind, all students take calculus. This is the y value. Notice the y value is the same. So we plug it in, and even though this is going a negative direction here, so we have a negative angle, negative radian angle, positive radian angle. This is the positive 1.266 angle to get me the y value of 0.3. I know it's a little bit confusing because I'm marking this as 0.3, but because my variables are switched here, I'm switching them on the graph. And we're looking now as this means my arc, not my, it's my arc length, not necessarily my y value there. So my arc length here, or my radian measure, would be negative, this is positive 0.266. But in both cases, you end up getting a line up here, and with the cosine, this quadrant and this quadrant are both positive. So that's why 0.3, when you plug it in, you end up getting two different values, or you can get two different angles that give you that same 0.3 expression. Because that will happen, like if we were dealing with arc sine, you'd get two different values for this one and this one. Get two different angles that would give you the same expression. And same thing for tangent. We have general solutions. So for arc cosine, so to find arc cosine of 0.3, to get both arcs as answers, our general solution ends up looking like this. We have plus or minus the inverse cosine of 0.3. That gets me that 1.266, the plus and the negative version of it. And then adding 2 pi n, this is just adding a whole nother revolution. So this is like the coterminal angle stuff. So you're covering all of your bases. Because technically, if you keep going rotations, you're going to keep hitting that value over and over and over again. So you could have infinite number of solutions. The plus minus sign tells you that both the calculator value and its opposite arc are values of arc cosine of 0.3. And then the 2 pi n tells you to add or subtract another revolution to get more values of arc cosine of 0.3. And if you want to mark this, these are coterminals that we're talking about here. So here, note, the value you get from the calculator is called the principal value because it's the answer in the principal branch. I know we talked about this a little bit when we were talking about inverse cosines, but remember how, like, that's a sine or a cosine function. And then with inverses or opposite functions, it flips it over a line. And when you flip a function like this, it ends up looking something like that. So it doesn't pass the vertical line test. So with an inverse function, it only focuses on a principal branch. And for like this, it'd be from here to about right here, because then it would cross the vertical line test before it starts coming back and repeating itself. So the answer that the calculator gives you will always be an answer in that principal branch, in that one cutout. It cannot give you all the different solutions that can happen given a y value. So remember, this 0.3 is my y value. If I was to graph that in like this is 0.3, it's going to keep hitting over and over and over again. You're going to get an infinite number of solutions. And that's what this means. There are infinite answers. So I don't want you to write out every answer because it would take you a lifetime. So we use these general solutions to write an expression that gives me all of the answers. Okay, flip. So we're going to write down the general solutions. I usually go into more detail with all of this, but I'm trying to cut down to what you absolutely need. So instead of proving and showing all these sine, cosine, tangent stuff, I've showed you cosine. We've talked about that. And then I'm going to give you the general solutions for sine and tangent without really diving any deeper into those this time. Okay, so for arc sine, I'm going to write it like that. That would be what we're trying to solve here. The general solution will look like sine to the negative 1 of a plus 2 pi n. And you can use arc sine or sine to the negative 1. It doesn't matter. And then it also is equal to pi minus sine to the negative 1 of a plus 2 pi n. These are called supplementary answers, because keep in mind that you're getting the solution in the first quadrant, but then you're also getting the solution in the second quadrant. And so that's where this pi minus that comes in, because it'll give you that same arc. So if it takes you, I don't know, 30 degrees to go this way, to get your other 30-degree angle in the second quadrant, you'd have to take pi and subtract that. So that's what that's representing. See all of your answers. And then for cosine, we've already touched on this one, so I'm just going to repeat it here. These are opposite answers. And that's because you have all, and then you have C in the fourth quadrant. So it gives you the positive version of the angle and the negative version of the angle. And then tangent, a little special too. You have tan to the negative 1 of A, which gets me my arc value. And then we're going to add half a revolution. And that's because with tangent, you get the answer in the first quadrant, and then you get the answer in the third quadrant. So you get the answer here, and then you add half a revolution to get your answer here. And so it gets answer, 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 answer. So that's why you add half a revolution there. All right. And we should probably write that, half a revolution. Answers. All right, interval notation. Now, for interval notation, I don't think we've talked about this yet, but this is just a different way of writing domains of functions. So I'm just going to write some, I'll write 3 expressions, and then we're going to describe what that means. So if you have brackets, and then it kind of looks like an ordered pair, but it wouldn't be an ordered pair, because it would say something like x is an element of. That's what that means, x is an element of. Then you'd have brackets, and then a range of values from 0 to 4 pi. The meaning of that is that your x value is between 0 and 4 pi or equal to. So the brackets, close it in, that means that you have equal to bars. This is called a closed domain. The second way an interval notation can be written, and I guess I should preface this with saying, you're going to start to see this now in problems, and so you'll see domains written like this instead of like this. So we need to be familiar with this. Another way it's written is with parentheses. What this means is that x is between 0 and 4 pi, but does not include 0 or 4 pi. This is called an open domain. And then you can have a bracket and a parenthesis, and those can be flipped too. What that means is that one of your inequality signs is equal to whatever has the bracket, the other one is open. So this is a half open domain. Okay, so it's just cutting down what you have to write, basically, and this is the more, I guess, concise way or mathematical way to write a domain. You go from a range of values like that and just write it with different notation. So you'll see this expression coming up here every once in a while. All right, let's go ahead and flip. Okay. I think I have enough time to do one example here. Yes. Okay, we're going to do example 1, and then we'll hold off on example 2 and 3 until tomorrow. Okay, so for example 1, I want us to find the first 5 positive values of y equals 9 plus 7 cosine of 2 pi over 13 x minus 4 when y equals 5. And we're going to do this 2 ways. We're going to solve it algebraically first, and then we're going to look at the graphical way to solve it. Okay, so algebraic. They're giving me a y value, so I'm going to go ahead and plug that in for y. And then I'm going to isolate my trig function. So I'm going to subtract 9, get negative 4 and then divide by 7. So you get negative 4/7 equals cosine 2 pi over 13 times x minus 4. So this is all in the argument of cosine, so you can't really do anything with that. Like, you can't add 4 or anything like that because this is all glued together in the function cosine. So I got to get rid of the cosine now. To get rid of the cosine, I'm going to take the inverse cosine of both sides. Cancels out on the right-hand side. And you're left with cosine to the negative 1, negative 4 over 7. Sorry, equals 2 pi over 13 times x minus 4. Okay, so I should write steps. I'm sorry. Up here, we isolated cosine. Here, we take the inverse cosine of both sides. Now remember, you can label it as arc cosine, and technically arc cosine would be more correct because arc cosine gets across the idea that you're looking for all of the angles and arcs. That would give you that answer. Cosine to the negative 1 is kind of the calculator version of it that just gives you the one answer. But since it's part of my general solution, I'm just going to keep it. And then I'm going to get x by itself. So I'm going to multiply by 13 over 2 pi. So in this step, I'm going to isolate x. So you get 13 over 2 pi times cosine to the negative 1, negative 4 over 7 equals x minus 4. Okay, so I just multiply both sides by 13 over 2 pi, which canceled that out. The reason I didn't distribute this first and then do that is it just makes it cleaner and easier to multiply by the reciprocal first to get rid of it instead of distributing first and getting a lot of fractions. Then to solve for x, I'm going to add 4. So I get 13 over 2 pi. Okay. Now, you know what? I should have used arc cosine. I'm going to change this on you. I'm sorry. The reason being, let me get it there. I'm going to rewrite this. You'll see here in a second. I won't make that mistake again. Okay, the reason I want to write it like this is because this expression looks like what I have here. We have x equals arc cosine of an argument. And so this section here, this arc cosine of the argument, is going to change to be this. Okay? So the 13 over 2 pi is unaffected. It just stays put. And then this arc cosine of negative 4 over 7, that's going to change to plus or minus cosine to the negative 1 of a. So here, plus or minus cosine to the negative 1 of a plus 2 pi n. Okay, so this was replaced with what it's equal to in terms of the general solution. And then we add 4. Now, I'm going to stop there because when I go back up here, find the first 5 positive values of that. This is where we use our graphing calculator and our table to come up with those solutions. Because technically we have two equations here. So, in your graphing calculator, we're going to put the 13 divided by 2 pi, okay, that piece, multiplied by the positive version of inverse cosine, negative 4 over 7, and plus 2 pi, and then for x, or for n, I'm just going to use x. I'm going to close that parenthesis, and then add 4. Okay, and then I'm going to do the same thing here. except I'm going to make it a negative cosine to negative 1, negative 4 over 7 plus 2 pi x plus 4. Okay, and then as long as my mode is in radians, and I go to my table, I should see, if I delete all my values there, I should see this. Now remember that x is the amount of revolutions that you've gone around. So, let's say I don't go around any revolutions. That's what x means here. I get those two values. And I should say, oh, first 5 positive values. I'm going to go around another rotation. I'm going to go around another rotation. I don't know why it's giving me an error. Why would it give me an error? I don't know why it's giving me an error. Let me just check this. No. Oh, there we go. Okay, so for the first 5 positive values there, we have 8.5. I'm going to go round to 3 decimal places, so that's my first one. 8.509. My next one is 12.492. My next one is 21.508. My next one is 25.492. My last one is 34.508. So, these are all the arc values or radian measures that would give me the value of 5 later. Here, we forgot to write a step here. Here we replaced arc cosine with the general solution. Okay. So I think that's where we'll leave off today. I would encourage you to at least go back and just re-watch this, unless you feel like you got it the first time. And when we come back tomorrow, we're going to do example 2 and 3 together in class, and then we're just going to get a lot of practice on this, plus with what we've been doing. So that's it for today.